Hello everyone. So today we will be going to another model. We will be discussing another model. So let us start. So we'll be starting by checking first of all whether the Indian design codes are selected or not. So it is selected. And first of all, whenever you open your state profile, you should open it by running as administrator. Okay, that you should always remember. So then you select Indian design codes, then new project. So in the project, I have to select space. Then let us go to the second one, second structure. Okay, let us today go to a new structure. So in the same folder where I saved my previous file, I am saving this new file also. So you select whatever folder you have made for saving the files. You select that folder and then you give that location. I have given this location. Then meter and kilonewton I have given. Then next, then add beam, finish. Then I have to go to geometry, run structure wizard. Now in run structure wizard, uh, we have to select frame models. Okay, so bay frame. So when you select on bay frame, you will be getting an option of length, breadth, and height. Okay, so now when you select a model, suppose now this model has like 4 floors. Okay, and along the horizontal direction, suppose there are 3 bays. Okay, so suppose let me give the dimensions in that way. Suppose height is 15. Okay, 15, and each floor is 3 meter height. So number of bays along height is 5 bays along height means 5 floors. Okay, 5 different items. Five number of bays along height. 5 means what? 5 different sections or items along the height. So 5 different floors. Okay, so when you select this dotted icon, you'll see that each floor is already divided into 3 3 3 3 3. Okay, so it divides it automatically. Now along the length, let me take dimension of uh, like 11 meter. Okay, along the length. So let me give 3 partitions along the length. Okay, and let's give 3. So when I give 3 partitions along the length, then it divides the 3 partitions along equally 3.66, 3.66, 3.66. Now let me do it on my own. Let me give partitions of 4, 3 and 4. Okay, along the length. Now along width, let me give a width of let me give a width of 9 for the frame, and number of bays let me give 2 along the width. So it divides the number of the width into 2 equal parts, 4.5 and 4.5. So you can also divide it according to your customization. So 5 and 4 let me give. So this is the way I give the partitions in frame. This is a custom model. Okay, custom I have given. Okay, height I have given 5 bays means 5 floors. Okay, so each floor it has already been divided into 3 3 3 3 3. Then along length, a frame will have length width also, isn't it? So length, total length is 11 meter of the frame. So I have given it into 3 parts, and each part I have given one part 4 meter, one part 3 meter, one part 4 meter. Again, along width 9 meter I have given width. I have divided it into 2 parts, and one part is 5 meter and another part is 4 meter. So now if I apply it, so you see I have generated the model. Okay, so now I will transfer the model by clicking here. So now I click OK. So the model is transferred. Okay, so you can see here, this is what I have given the lengths of 3 meter along the height. I have, it is what, 3 meter, 3 length 3, we can see here length 3 is given. So everywhere the height is 3 because we have given height 3, and along the length what we give 11, isn't it? 4 3 4. So this one is 4 length 4, this one is 3 length 3, this one is 4 length 4. Along the width I have given 5 and 4, isn't it? So if you want to see the, if you want to have a closer look, you can just scroll it. Okay, scroll the ball of the mouse and you can view it more closely. So along the width you can see first one 5 and this one is 4. So in this way we have given the dimensions. Okay, so I hope you have understood it. Now after this, let me give the cross sections. So once again I am doing it fast. Define, let me give a rectangular cross section. Okay, first of all let me give a rectangular section of uh, 350 mm by 450 mm. Okay, material is concrete. Okay, done. Then again I am giving a rectangular section of uh, 350 by 350 square section. Okay, add. Okay, so I am giving the square sections to the columns. So when I select this, I have to select beams parallel to Y and then assign to selected beams, assign. So concrete is done. Okay, these columns have been assigned square cross sections of 0.35 and 0.35. Then 0.45 by 35 I want to give it to the beams. So now I select this one, then select beams parallel to X and also along with it beams parallel to Z. Then if I click assign, so beams are given this section. So now let me do the 3D rendering. You can see the frame is made. Okay, the frame is already done. Now let me give the supports. So general, let me give the supports. When you click on general, then you click on support. So create support, then fixed support. Let me give fixed support, add. So this support, now you have to select the nodes, isn't it? So for selecting the nodes from in the 3D model, it becomes a little bit difficult. So I have one idea. You go to this view, front view, and you select like this as a whole. Okay, then if you again go to the 3D view, you will see that the whole all the nodes at the end are selected. Okay, so assign to selected nodes, support, assign. So now all the supports are given, all the supports are provided with fixed supports. So this one, if you look into the 3D view again, you see the supports like this. Okay, so supports are given, then your sections are given. Okay, now let us go to the loading. So when you go to the loads and definitions, first you have to give the, suppose you want to give the seismic definitions. Okay, so because you will be doing the earthquake load, isn't it? So you will be dealing with the earthquake load. Now when you click on seismic definitions, click on add. Okay, then seismic parameters. So these seismic parameters, uh, you have to select your own IS code, IS 1893-2002. Okay, then generate. Now you always have to remember one thing. Always select the definitions at first. In the loads and definitions tab, you always have to select the definitions at first, then the load case details. Okay, the software is very much sensitive about the steps. Okay, like this step you have to do at first and this step you have to do second. Okay, so which step you are doing at first and which step you are doing at second, it matters to the software. Okay, you cannot do the dead load at first and live load at second and then the earthquake load. It's not like that. You have to first give the definitions of earthquake. Okay, you have to give all the definitions of the earthquake if you are doing the earthquake analysis. Then you go to the you can say dead load, live load. Okay, so that's why I am starting with the earthquake definitions. So once again, you go to general, loads and definitions. So definitions, add. So you can say seismic definitions. Okay, so add. Now one second. Because we'll be doing the earthquake analysis, so add. Now seismic parameters, you have to select IS code, our Indian IS code, then you click on generate. Then it depends on the city that you are working. Okay, so here I'll select Guwahati. Then what type of frame you are working with, special moment resisting frame, ordinary moment resisting frame, all those things you need to give depending on your model. Okay, then important building or all general building, these things you will get in uh, like in your IS 1893. Okay, so I recommend you to go through the IS 1893 because you see you have to finally do the analysis of your major project model in StaadPro. So these conditions, special moment resisting frame, important building, all those things you have to discuss with your guides and you have to apply the values here. And rock soil type also, whether you are making it in a hard soil, making the structure in a hard soil, in a medium soil or soft soil, it depends on your project work. Okay, so you have to give these datas from your project. Okay, so RC frame building. Okay, so now these things you don't have to do it here right now. Foundation depth and all, foundation we will be doing manually. Okay, so all these things, so I have shown you. You have to input your own major project values here. Okay, whatever building you are doing, you have to input those in this tab. So now after suppose you have selected this values, you click on generate. Okay, so you add. Okay, then you can see here there is one new zone 0.36 RF5. All these things have come, so that means the software has taken your earthquake definitions, what type of earthquake you are using. Then self-weight factor is one thing that is required with the seismic definitions, so you add it, then close. So this is how the seismic definitions are done. So you now minimize it Okay, then load case details is the second. Okay, so load case details you select, and then you select add. So first one, uh, you select here seismic. Now earthquake will be in four directions. Not four. Yes, four directions. One is y is vertical, so earthquake will not be in vertical direction, obviously. So one is in x direction and other is in z direction. So x also, like earthquake can go from either left to right or from right to left, isn't it? Z direction also, it can go in either way, isn't it? In z direction it can go either way, in x direction it can go either way. So it depends. Okay, so for every direction I need to give the earthquake. So x direction, one way I give positive, another way I give negative. Okay, in z direction also there will be one positive and one negative depending on the direction. So load case details, add. So first I will give seismic. For earthquake x direction there will be two EQ, one I will take x plus. So x in the positive direction, add. Then number two, earthquake in the negative x direction. So two directions of x will be, isn't it? To and fro along x direction. So I'll give EQX minus. Then along z also, there will be two directions, isn't it? Earthquake will happen in two directions. So one I give EQ Z plus, add. Then another I give EQZ minus, add, close. So this I have given EQX plus. So now this is just the name that I have given EQX plus. The software will not just understand from the name itself that the earthquake is going in the positive direction of x, or number two, from the name itself the software will not understand that the earthquake is going in the negative direction of x. So we have to make the software understand that EQX plus, the name EQX plus ultimately means an earthquake which is going in the positive direction of x. So what I have to do is EQX plus I need to select by left single click, then add. Then this we have to go to seismic loads. Okay, so x is given and factor is 1. So now it means it is going in the positive direction of x. So once again my toolbar is giving me problem. So I am now adding it. Okay, now EQX minus. So now I give here add, then I go to seismic loads, factor x, you have to select x, it is there, minus 1. Okay, now add, close. EQZ plus, so again I add, like in this direction, z, sorry, seismic loads, z direction, factor 1, add, close. Z minus, add, then seismic loads, factor minus 1, add, close. So in this way I give the load case details. Now Load case definitions, I have given the earthquake definitions. Then load case details, I have given the details for earthquake plus x plus direction, x minus direction, z plus and z minus. Now let us give the dead loads. Okay, today we will be concentrating on applying the dead loads. Then in the next class we will be doing the analysis. Okay, so load case details, you select, add. Number 5, so 4 we have already given, eq x plus eq x minus eq z plus eq z minus. Number 5, dead load. So let me give the name as dl, add, close. Now again you select load case details, add, select live. So I'll write the name as ll, add, close. Okay, so you have to understand that first of all definitions. Okay, definitions are done. Then in load cases, first of all earthquakes plus minus z plus z minus done. Then dead load. Let me apply the dead load. So what will be the how will we apply it? So let me click on dead load and you select add. So in dead load, two loads will be falling. Okay, two loads will be falling uh, on the beams. First of all, not two loads, there will be three loads. Okay, so one will be the self weight. Okay, then another will be the slab. Okay, and next one will be the wall load. Okay, so suppose in a particular beam there will be both dead load, both the self weight of the beam, or let me take this beam. Let me take this beam. In this beam there will be both self weight, then the load of that slab, okay, which is connected to the beam, then load of the wall on the beam. So three loads, okay, in this beam: self weight of the beam, load from the slab on this beam, and load from the walls on this beam. So first of all, for self weight, what we have to do is you select dl, add, self weight, factor in y minus 1 direction, obviously, because self weight is going in the self weight is nothing but gravity load. It goes in y direction and in the negative y direction. Okay, so that's why I have to select this one, self weight load y minus 1, add, close. Okay, so now this self weight I have told, I have added a data for self weight in the software, but I have not applied the self weight. I have not told the software yet to calculate the self weight. Okay, so I have to tell the software that I have to calculate the self weight of this whole structure, isn't it? So how will I do it? It's simple to how you calculate, how you apply the sections for the beams and columns, the rectangular sections. So for self weight, same way, you select the self weight, then you select the whole structure. Okay, and then you assign to select beams and plates, and then you click yes. So now the self weight has been assigned. It is similar to how you first gave the how you first added the cross sections 0.35 by 0.45, 0.35 by 0.35, then you applied it to the frame. Same way, the in the dead load I gave the self weight, and then I selected this whole building and I assigned it and ultimately the self weight is assigned. So now the beam, the whole building self weight is now taken into consideration. Okay, now let us calculate the load of the slab. So the load of the slab will be taken as floor load. Okay, so dead load, I select add, I select floor loads, then the floor load is given in the form of pressure. Okay, so floor load is given in the form of pressure. So once again show you dead load, add, then you get floor load. So pressure, what will be the pressure? It depends on what is the thickness of the slab that you are giving. So the thickness of the slab is, suppose, 120 mm. So it will be 0.12 meter, isn't it? If the thickness of the slab is 120 mm, it means 0.12 meter, and unit weight of the slab will be the unit weight of concrete. So the load from the slab will be, the pressure load will be thickness into unit weight. So thickness is 0.12, that means 120 mm, 0.12 into 25. So it will be how much? 3. And 3 kilonewton per meter square. 25 into 0.12, and it will be minus 3. Okay, and now it will be in the y direction. Okay, because slabs, the loads are giving in the y direction. Now from where to where do we apply the slabs loads? From slabs are from this level, if you can follow my cursor, from this level to this level, right? So what is the height at this level? 3 meter, because all the floors are 3 meter. So this height is 3 meter, then 6, 9, 12, 15. So minimum range of the slab is 3 meter, and maximum range of the slab is 15 meter. Okay, so here I am giving, I'm checking it once again. Floor load y range, it will be in the y direction, global y minus 3, which is 25 kilonewton per meter square into 0.12 meter thickness of the slab, and range is 3 meter to 15 meter. From here 3 meter to 15 meter. So I give and close. So I have given the y range. When you select here, you can see how the loads are being applied. Okay, when you select it, you can see directly how the loads are being applied now. Okay, now if I go to the top view, you can see this is called trapezoidal loading. Okay, you will be doing it in your major project soon, very soon. You have to calculate the trapezoidal areas of the slabs, and then you have to find out the loads and loads falling on the beams and all. So those calculations you need not do in StaadPro. Now StaadPro is doing it automatically for you. Okay, now self weight we have considered, then floor load we have considered, then another load I need to consider, which is the wall. So what are the, how will we find out the wall load? So wall load will be for this beam, this beam, this beam, and this beam, isn't it? Wall load will be for these beams. For this beam there is no wall load, isn't it? For this beam there is no wall load. Wall load is there for this, and this. So for calculation of wall load, the formula is thickness of wall into height of wall into unit weight of wall. That will be the wall load. So thickness of wall, let us consider the thickness of wall as 150 mm. So it will be 0.15 into height of wall. Height of wall, floor height is 3 meter. So height of wall will be like floor height minus depth of beam, because beam is taking a certain height, isn't it? So let us consider 2.65 meter wall height. Okay, because uh, beam is taking some depth, isn't it? So beam is taking maybe, if I look into the cross section, how much beam is taking, geometry, general, 0.45 depth of beam. So total height 3 minus 0.45 will be, uh, it will be 2.55. Okay, so wall height will be 2.55. Out of floor height of 3, wall height is 2.55. Into thickness is 0.15. Into unit weight of wall is 20. So finally, how much do we get? Let me just calculate. So 0.15 wall thickness into height of wall 2.55 into 20. So you get 7.65. So wall load is 7.65. Now in dead load, I have to add the wall load. So you select this dead load, then you wall. Wall load will be in the form of what? Uh, Wall load will be in the form of UDL. So you have to give it in member load, uniform force. Wall load will be like this. Okay, so now I will give the load of wall. I forgot the value of the wall. I just check it once again. 0.15 thickness into 2.55 into 20, unit weight 7.65. So it will be minus 7.65 wall load. Okay, and it will be falling in the y direction. Okay, and you add it, then close. So wall load. Now wall load, it is showing a question mark. So it means that we have not assigned it to the frame right now. We have just told the software that there is a wall load of 7.65 kilonewton per meter. Okay, we have not assigned it. It's the same thing with geometry. Okay, so when we tell the software that there is two sections, 0.45 by 0.35, 0.35 by 0.35. We tell the software that there are two sections, then we assign it to the frame. Same way, we first tell the software that there are these loads and all, then we assign it. Okay, so now how will we assign it? This will be assigned to the beams, right? So what I will have to do is, you select here, and then I will select the beams. So one easy way of selecting the beams will be like going in this direction. Okay, then select there, then you press Control. In the top wall, in the top beams there is no wall, so I will not apply it here. Okay, so if you now see the 3D view, we can see that these beams are selected. Okay, so walls will be above these beams. Okay, now assign to selected beams, you select assign. Yes, so wall load is done. So in this way, self weight is done, slab weight is done, wall load is done. Then next is live load. Live load is given in the form of floor load, and for residential buildings it is taken as 2, and for commercial buildings it is taken as 4. Okay, so let me take it as a residential building. So live load, I click add, it will be floor load, pressure minus 2, and it will be, since it will be in the form of slab, so we'll take it from 3 minimum range 3 from this range, okay, to 6, 9, 12. So let us assume that in the top there is no live load. Suppose let us take it throughout the whole height, 3, 6, 9, 12, 15. So up to 15, since it is in the form of a floor load. Live load is, see why it is taken as a floor load, because live loads are acting on the floors or the slabs, and from the slabs the load gets transferred to the beams and columns. So that's why, since the live load gets transferred to the beams and columns through the slabs, so that's why we take it as a floor load. And in IS code it is already given for residential buildings it is -2, for commercial buildings it is -4, sorry, 2 and 4. For StaadPro I have to give -2 for the directions. Okay, now you click on add, okay, and close. So that is the way how we apply the loadings. Okay, so I hope you have understood it till now. Okay, uh, so in the next video I will be telling you about load combinations and analysis. So thank you very much.